Properties of exponents. To define exponent notation, the base is the number that is going to be multiplied to itself, and the exponent is how many times you multiply the base to itself. The first definition is everything has an exponent of 1, whether it's a variable or a number. Every base has an exponent of 1. Just like the coefficient 1, you won't see the exponent 1. So a number has an exponent of 1, and a quantity that's raised to a power 1 is just simply what the quantity is. So everything has an exponent of 1, or if you have to simplify something that has the exponent of 1, it's simply the bases. Next property is anything raised to the 0 power equals 1. Anything raised to the 0 power equals 1. So if I have 5 to the 0 power, it equals 1, not 5. If I have a quantity raised to a 0 power, it equals 1. Okay? So now, be careful when 0 power is mixed into a problem, because if I have x to the 0 power but I have y squared, that x to the 0 power is being multiplied to y squared. The x to the 0 means 1, and it's 1 times y squared, so therefore I get y squared as my answer. So when you have something to the 0 power mixed in, the only thing that equals the 1 is the base with the 0 power. And when it's multiplication, you're multiplying by 1, so you're simply going to get what you're multiplying to, which is that y squared in this case. Pause and try. So again, that x to the 0 power equals 1. We have multiplication here, it's 2 times 1. So my solution here, when I simplify, would be 2. Pause and try. The whole entire quantity is raised to the 0 power, therefore this equals 1. Our next property is the multiplication property. And when we have like bases being multiplied together, what you do to simplify is you take the exponents and you add them together. So when you have something like this, where you have 2 to the 4th power times 3 to the 3rd power, we need to simplify. And the way to simplify here, because they're like bases and the base is 2, I'm going to add the exponents. So I end up getting 2 to the 7th power. Be very careful when there's numbers involved and not just variables, because we have a tendency to want to multiply the numbers together first and then add the exponents. But that is incorrect, because order of operations states exponent has to go first and then you multiply. So that's why in this case you have to add the exponents together with that like base, and then you could actually multiply it out by using 2 to the 7th power. So be careful when you have numbers as bases and they're raised to powers. So in this case, you see I have z to the 6 times z. Don't miss that exponent of 1. Z has an exponent of 1, but we won't see the exponent of 1. So we need, when we multiply together, to keep in mind that if we have a base, then we do have an exponent, and that exponent would be 1. So when I simplify this, I'm going to end up with z to the 7th power. Pause and try. So you should have gotten 3 to the 5th power. Pause and try. So in this case, remember that x has the power of 1, so we should get x to the 9th power. Our next example that we're working with is just a combination where we have bases with powers and we have multiplication. Now, multiplication is multiplication. When you have numbers that are being multiplied, you multiply the numbers. So that 3 is being multiplied to 7. And then the like bases with the powers, you would add the powers together to simplify. But don't forget, multiplication is multiplication. You need to multiply numbers together. 3 times 7 will be 21, and then like bases, you add the exponents, you end up getting k to the 8th power. When there's a multiple things going on, be careful. Make sure the numbers get multiplied together, and like bases, you add the exponents. So in this case, I end up getting 12 times 2, which is 24, and then x squared times x, which really has a power of 1, you get x to the 3rd, and then y to the 5th. Pause and try. So you should have gotten negative 2 times 4, and then you have x times x to the 5th, which will give us a negative 8 x to the 6th. Pause and try. So in this case, we will get 3 x to the 10th, y to the 8th. So it's very important that you put the number in front. It's a coefficient. So when we have division of like bases, the division property is you will subtract the exponents. And you don't want a negative exponent, so you're always going to subtract where the highest exponent. So if the highest exponent is on top, you'll have a whole number or a whole part, and you'll subtract and it'll leave it on top. But if the highest exponent is in the bottom or the denominator, you will subtract and you will end up with a fraction. So it's very important that when you do division, you're subtracting, but you're leaving where the higher exponent is. And if the higher exponent's on the bottom and nothing is left up top, you need to put a 1 over it so that it represents that fraction. So here's an example. We have x to the 5th over x to the 3rd. It's division. The highest exponent's on top, so I'm going to subtract the 5 or the 3 from the 5, and it's going to end up being x to the 2nd power. So the higher exponent's on top. When I simplify, I get x to the 2nd. When I have y to the 5th over y to the 8th, it's division, and I have to subtract the exponents, but because the highest exponent is on the bottom, I'm going to subtract and it's going to stay on the bottom. So we end up getting 1 over y to the 3rd. Now when you have the same thing over the same thing, this is that property of 1. So again, if I subtract the exponents here, I'm going to end up getting a 0 power, and anything raised to the 0 power equals 1. And also the division property for fractions is when you have the same thing over the same thing, it equals 1. So this is where the 0 property comes into play. When you have something raised to the 0 power, it equals 1. When you divide the same thing over the same thing, you get 1. Pause and try. So you should have gotten x to the 4th, and again the higher exponent's on the top, so you end up with a whole part, x to the 4th. Pause and try. The higher exponent's on the bottom, so I'm subtracting and it's going to stay on the bottom. I get 1 over z to the 6th. Pause and try. Again, it's like bases, so you're going to use the division property. You're going to subtract exponents, and you're going to end up with 15 to the 1 power, which is 15. So now this is a combination. Whenever we have a combination, I like to separate it into 3 separate problems and simplify piece by piece. So by doing this, because it's division, I like to write my division line. And then I just look at piece by piece and simplify and put it where it belongs on this line. So when I look at the first piece, again, be very careful. It is a fraction that needs to be reduced. We're not subtracting here. It is a fraction that needs to be reduced. 5 over 15 will reduce to 1/3. And then I look at the next piece, and the higher exponent's on the bottom, so I'm going to subtract, and it's going to stay on the bottom. And because I already have the 1 up top, I don't put another 1 up top. Once something's left up top, you don't need to put anything else. So when I subtract, I'm going to put it on the bottom. And then the last piece, I see the higher exponent's on top, and I'm going to subtract, and it's going to stay on top. So when I simplify, this is what it would look like. Now, because we don't have a coefficient of 1, or we don't see the coefficient of 1, I'm going to take that 1 on the top out of my answer because I have y to the 6th on the top. So that's how I would write my answer. Pause and try. So again, I'm writing my line. I'm simplifying the 3/9, and it's going to be 1/3. And then the x to the third, x squared, the higher exponent's on top, I'm going to subtract, and it's going to stay up top. So I get x. And then the y over y to the third, I subtract, and it's going to be y squared on the bottom. And you don't want to leave that 1 with the x, so you end up getting your x over 3y squared. When you're solving this, do it piece by piece. Make sure the numerical part is a fraction that needs to be reduced. Pause and try. So in this case, I write my line, and I do the 8 divided by 2. 8 divided by 2 is going to be a whole number. It's going to be 4, so it's going to be on top. And then I see my x to the 5th over x to the 4th. The higher exponent's on top, I subtract, and I leave it on top. And then y to the 0 power equals 1, and 1 times anything will just be what you have. So I end up just getting 4x, and I don't have it over anything, so my answer is simply 4x. So now this is the power to a power property. And when you have a quantity raised to a power, and what's inside has a power, to simplify, you're going to take the two powers and multiply them together. So power to a power, you multiply the powers. So in this case, you have w to the 6th power raised to the 4th power. Well, to simplify here, I'm taking the two powers and multiplying together. So I get w to the 24th power. So here we have s to the 0 power raised to the 4th power. Well, when I multiply the powers together here, 0 times 4 is going to equal 0. Therefore, my solution will be 1, because I still have s to the 0 power. Pause and try. So you get 5 to the 15th power here. Pause and try. You get x to the 18th power. So now the next property is the power of a product property. So when you have a product and it's raised to a power of a product property, we have a quantity raised to a power. When we have a quantity raised to a power, you're going to take that power on the outside and you're going to give it to everything inside. So in this case, I have a quantity xy, and it's raised to the 2nd power. To simplify, I need to take that power on the outside and give it to everything inside. So I end up getting x squared, y squared. Be careful when you have a quantity raised to a power, and inside you have a number. That number needs to get that power. Don't miss the numerical part. So when I do this, I'm going to end up getting 2 to the 3rd power, x to the 3rd power. Now you're going to need to simplify the 2 to the 3rd power, and remember, 2 to the 3rd power means I have 2 times 2 times 2, which will multiply to 8. So when you have a numerical part and a quantity to a power, you're going to have to take that power and give it to the number, and then you're going to have to evaluate it. So you end up getting 8 to the x to the 3rd power. Be very careful here not to fall into that problem of taking the number and just multiplying it to the power and getting 6 instead of 8. It is 2 to the third power. It's not 2 times 3. So be very careful when you're doing the evaluation. Pause and try. So again, we have 3 to the third power, z to the third power. And then I evaluate 3 to the third power as 27 z to the third power. Pause and try. So in this case, you should have gotten 25x squared y squared. So now we're going to do a combination of the properties. So I'm going to be using the power of the power property and a quantity raised to a power. So when I have a quantity inside and they have powers, when I take the power on the outside and give it to everything inside, I need to use the power to the power property. So I'm going to take that exponent on the outside, that 2, and I'm going to give it to the x squared and the y to the 6th. And when I do that, I'm going to have the power to the power, which means I have to multiply it to the powers inside. So when I simplify here, I'm going to get x to the 4th, y to the 12th. So when you have the combination properties, be very careful not to miss the numerical part. So this numerical part needs to get that power also. So I'm going to end up getting 3 to the second power, and then I have y to the 5th, and it's a power to a power. I'm sorry, x to the 5th, and it's a power to a power. So I end up getting x to the 10th, y squared, and then z to the 6th. And then you need to evaluate the numerical part. So you end up getting 9x to the 10th, y squared, z to the 6th. Pause and try. So you should have gotten 27, x15, y12. So now I have a combination multi-step operation of exponents, or properties of exponents. So the first thing we're going to need to do is we're going to need to do those power to the power, or the power to the quantity property. So we have power to a quantity and we have power to a power. So I have to first simplify piece by piece. So I'm going to work with the first quantity. I'm going to take that power on the outside and I'm going to give it to everything inside. And again, that negative 2 is being raised to the third power. I have a to the third power, and then I have b to the 6th because it's a power to a power, so I end up 2 times 3, which is 6. And then I'm going to simplify the second piece, and that is a power to a power property, and it's being multiplied to this piece we just simplified, so I'm going to end up having a to the 8th. Now we have the multiplication property. So I'm going to simplify the negative 2 to the third power, which gives me negative 8. But then that multiplication property, when you have like bases being multiplied together, you add their exponents. So I'm going to end up getting a to the 11th here, and then I'm just going to bring down the last piece, b to the 6th. So this is simplified. So be careful in the order in which you do your properties. Pause and try. So I do the first piece first. I get d to the 21st, e to the 9th, times, and I do the second piece, and it's 3 squared, which is 9, d to the 10th, e squared. Now I have the multiplication property where I'm adding exponents for like bases. Remember, the numerical part needs to go up front, so I end up getting 9 d to the 31st, e to the 11th. Similar to a quantity raised to a power, when you have a quotient raised to a power, that power on the outside needs to go to everything inside. So you end up getting something like this where you have a quotient x over y all raised to the 5th power. Well, to simplify, I need to take that power and give it to everything inside. So I end up getting x to the 5th, y to the 5th. So be careful when it's a combination of properties. I have powers inside and I have the quotient raised to a power. Well, that's going to be the combination of the quotient raised to a power and the power to a power rule. So you're going to take that power on the outside and multiply it to the powers inside. So when you do that, you're going to end up with r to the 16th over s to the 10th. Pause and try. So when you simplify this, be very careful not to miss that numerical part. A to the 5th, you get a to the 15th because you're multiplying those powers. Now remember, it's 3 to the 3rd power. 3 to the 3rd power is 3 times 3 times 3, which will give us 27. And then b to the 2nd raised to the 3rd power will give me b to the 6th power. So now when you have a combination of properties going on inside and it's raised to a power, the easiest way is to simplify inside first. Simplify all that stuff that's inside and then take the power on the outside. So when you're simplifying, again, I like to break something like this into 3 separate problems. So I'm drawing my line, I simplify the first piece, and 2 over 3 will not reduce any further, so I'm just going to write it in my solution area. And then I'm going to look at the next piece, and I see the highest exponents on the bottom, so I'm going to subtract and it's going to stay on the bottom. So I get a squared on the bottom. The next piece, the higher exponents on top, so I'm going to subtract and I'm going to leave it up top. So I get b to the 5th on top. Now that it's simplified, I'm going to take the power on the outside and give it to everything inside. So you're going to end up getting 2 to the 3rd, b to the 15th power, 3 to the 3rd, a to the 6th power. And now you're going to have to evaluate the 2 to the 3rd and the 3 to the 3rd, and you'll get 8 b to the 15th all over 27 a to the 6th. So simplify inside first before you take the power on the outside. Pause and try. So again, I want to simplify inside first. I'm just drawing my line. I'm looking at the first piece. 5 over 15 will reduce to 1/3. And then a7 over a to the 5th will simplify. I'm going to subtract and it's going to stay on top. I get a squared. And then b over b to the 4th, higher exponents on the bottom, I subtract and I leave it on the bottom. Now I'm going to take that power on the outside and give it to everything inside. And remember, we don't need that 1 because we have the a squared on top. So we're going to end up getting a to the 4th on top all over 9b to the 6th. So now we have something similar, but it's different because I have a quantity on top raised to a power and a quantity on the bottom raised to a different power. So in this type of problem, I can't simplify first because I have to take those powers on the outside and distribute it or give it to everything inside. So you have to know the difference between the two type of problems. So in this case, the first thing I'm going to do is take the power on the outside and give it to everything inside. So on the top, I end up getting x to the 3rd, w to the 5th, and then on the bottom, I get x to the 4th, w squared. And now I can simplify. So again, when you simplify, I like writing that line and looking at each piece at a time. The higher exponents on the bottom for the x, I subtract and I leave it on the bottom, so I get x on the bottom. And then the higher exponents on the top for the w, so I subtract and I leave it on the top, so I get w to the 3rd, 13, all over x. Pause and try. So be careful here because it's 2 to the 3rd power, which gives me 8. And then x to the 15th, y to the 3rd on top. And then I have 4 to the 2nd power, which is 16. And then x to the 4th, y squared. And now I'm going to simplify piece by piece. 8 over 16 will reduce to 1/2. x to the 15th over x to the 4th, higher exponents on top, so I'm going to subtract and leave it on top, so I get x to the 11th. And then y to the 3rd over y squared, higher exponents on top, I subtract and it's going to stay up top, so I just get y. And remember, I don't need that 1 because I have something left up there, so my answer will be x to the 11th y all over 2. So now we're going to deal with negative exponents. And negative exponents mean that my thing or my base is in the wrong position. And when the base is in the wrong position, you need to move it. So you're going to move and you're going to make the exponent positive. So the whole idea of the movement is to make the exponent positive because we don't want negative powers. So if I have a to the negative m power, that means that it needs to go under 1 in this case because there's nothing left up top. So I end up getting 1 over a to the m power. And I made the power positive when I moved it. So if you have 4 to the negative 3rd power, that really means I have 1 over 4 to the 3rd, or I have a fraction. And I need to simplify that piece, so I get 4 to the 3rd will equal 64. So my solution would be 1 over 64. So be careful. It's not a negative number. It is a negative power, and the negative power means I need to move and make the power positive. So when I have x to the negative 2nd power times y, well, y doesn't have a negative power. Therefore, my y is not going to move. The only thing that moves is the thing that has the negative power. So in this case, the y is going to stay up top, and then the x to the negative 2nd power will move under the y, and I would get y over x to the positive 2 power. Because the whole point of moving is to make the power positive. So now when you see something like this, be careful, because the only thing that's moving is the thing with the negative power. So again, 3 and a do not have negative powers. The only thing that will move here is that b to the negative 2nd power. So I end up getting 3a all over b squared. So only the thing with the negative power moves. So if the negative power is in the bottom, you want to move it to the top. And if it is simply on the bottom and you have a 1 on top, you end up just getting the b to the positive m power. So in this example here, I have 1 over x to the negative 3rd power. I want the power to be positive. Because the power is negative, it means it's in the wrong position, so that means I'm going to move it. And because it's in the bottom, it's going to move to the top. And because what's on top is 1, I'm going to just end up having x to the 3rd power. So be careful, because if you have a number other than 1 on top, and you have something on the bottom that's a negative power, well, it needs to move, but that 2 will not move, so you end up just getting 2 to the 2 times x. And you don't have the exponent of 1, so when you moved it up, you had x to the 1 power. Well, you don't need the 1 power, you just write the x. So be careful when we're talking about ones, negative ones, that when you move it, the power also is not shown. And this last one, you have to be careful. I have y over 2x to the negative 7th. Now the y doesn't have a negative power, and either does the 2. It's only the thing that has the negative power that moves. So in this case, all I have to do is move that x to the negative 7 up and make it a positive power, but the y and the 2 will stay where it's at. So I have x to the 7th times y all over 2. And again, you could have put x to the 7th after the y if you chose to. Pause and try. So in this case, you see you get 2x to the 6th. Pause and try. In this case, you end up getting 5 over x to the 3rd. Now look at this example. Again, they both have negative powers, and when they have negative powers, it means they're both in the wrong position. So I want to move and make them positive. So in this case, they'll flip, and we end up having the positive power. So be careful when you have negatives in a problem that the negative powers mean they're in the wrong position and they need to move. So in this case, you see I have 2 times x to the negative 5th power over 3 times x to the negative 7th. The 2 and the 3 do not have negative exponents. Therefore, the 2 and the 3 will not move, but the x powers need to move. So in this case, the 2 and the 3 stay where they're at. I move the x to the 7th up and make it positive. I move the x to the negative 5th to the bottom and make it positive. And when you see like bases, you're going to have to simplify. And this is the division property, and you have to subtract the exponents. So you end up with your solution here is 2x squared all over 3. So you will have to simplify your answer if it can be simplified further. Pause and try. So be careful here. The x to the 3rd goes up top, the 3 staying on the bottom, and the y to the 5th goes on the bottom. Pause and try. So when you switch it up, you end up with y to the 5th over y squared, and this can be simplified to y to the 3rd. So now when you have a combination property going on, I have a negative power on the outside and I have a quantity inside. Be really careful. I find that it's simpler to take the inside and flip it first and make that outside exponent positive. When you have a negative power, it means that everything inside needs to change. So when you do that, I'm not messing anything with the exponents. All I'm doing is I'm taking the top or the bottom and putting it exactly on the top. That x, y to the negative 2 power goes on the top. And then that x to the negative 1, y3, y to the 3rd power goes on the bottom. And notice that I changed the power on the outside to positive. So when you have a quantity and it's raised to a negative power, I find it easier to take the quantity inside and flip it first. Once you flip it, you change the power to positive. So when you're flipping, again, I want to tell this again. Make sure that you take exactly what you see on the bottom and write it on the top, and exactly what you see on the top and write it on the bottom. Don't worry about the negative exponents. We will work with that inside after we change that negative power on the outside to positive. So now that I have the outside power positive, now I'm going to simplify inside. So I want to simplify inside. So I'm going to take what we have inside and move the things that need to move. So that x on top, and then I have a negative, or x to the negative 1 on the bottom, that's going to come up top. And then that y to the negative 2nd power will go to the bottom, and the y to the 3rd will stay on the bottom because it's positive. And now I'll simplify the x times x. It's the product property. I'm going to add the exponents. I get x squared. Y squared times y to the 3rd will give me y to the 5th. And now I'll do the quotient raised to a power, and I'm going to take that power and give it to everything inside. So I get x to the 10th over y to the 25th. So again, I like to first flip the inside and change that negative power outside to positive, and then simplify inside. Pause and try. So I flip the inside exactly the way the top is going on the bottom, exactly the way the top was written. The bottom is going on the top exactly the way it was written. and I change that power on the outside to positive. I'm going to simplify inside first. That negative m to the negative power is the only thing that needs to move here. And then when I simplify, I end up getting m to the 7th on top. Remember, n to the 0 power is simply 1, and 2 times n. And now I'll take that power on the outside and give it to everything inside. Don't forget to give that power to the number, especially after we did all this work. You don't want to miss the numerical part, and that power or the whole problem will be wrong. So you end up getting m to the 14th all over 4m squared.